Hi everyone, so I wanted to make this video for the first part of your project. So I'm going to walk you through some steps of what might help you do better on the project. So this project is about solving literal equations. And what literal equations means is, if you jump down to it down here, that means there's just variables in the equation. Sometimes there'll be a number, but it consists of a lot of variables. So I'm going to show you how to deal with those because sometimes they can look a little intimidating. But we're just going to take it step by step, and I'll work through them with you. So we're going to start with just these one-step equations. These are very basic equations. You probably know how to solve them for a while now, and they're just one step. So when I'm solving this equation, what I'm trying to do is isolate the variable, solve for x. I want to get x all by itself. So right now I have x plus 5. So to get rid of this plus 5, I have to do the opposite operation, which would be to subtract 5, and we know we're going to do that from both sides to preserve the equality of the equation. So over here, my plus 5 and minus 5, that cancels out, that's a 0. And I'm just left with x. And on this side, I have 6 minus 5, which is 1. So you solved the equation. You isolated x, you got x all by itself. Yay! Let's do another one. So 14 equals y minus 3. Again, you're trying to solve for the variable. You want to get the variable all by itself. So if I want to get y by itself, I have to do the opposite of minus 3, which would be to plus 3. Add 3 to both sides. So on the left, 14 plus 3 is 17. And on the right, this minus 3 and plus 3 canceled out, leaving me with just a y. I isolated the y. Yay! Another one. 15 equals c divided by 3. If I'm trying to isolate c and get c by itself, I need to do the opposite of divided by 3, which would be to multiply by 3 on both sides. So on the left, I end up with 45. And on the right, I had this divided by 3 times 3. Those are opposite operations. They cancel each other out. And I just have c. I isolated c. I got it by itself. One more over here. So 2a, which is the same as 2 times a, that's what that means, equals 20. So if I wanted to get a by itself or isolate a, I would need to do the opposite of times 2. I would need to divide by 2 on both sides. So on the left, my 2's would cancel out, leaving me with a, and on the right, I get 10. So again, one-step equations, you guys have been doing these for a while now. But what I'm going to do now is I'm going to take that up a step. I'm going to take this same question, x plus 5 equals 6, except I'm going to now put 2 variables in there. And I still want you to do the same thing. I want you to isolate x, solve for x. Okay? So just like we did up here, to get x by itself, I need to do the opposite of plus y, which would be to subtract y. And I have to do it from both sides. So that looks a little funny here, but it's actually going to be the same process as above. So on the left, my plus y and minus y canceled out, and I just have my x left over, which is what I wanted. Here's the part that you might think is tricky, but it's actually not. On the right, I have to do 6 minus y. Well, I don't know what 6 minus y is because I don't know what y is, and that's okay. So all you have to write is 6 minus y, and that is your answer. That is how you isolate x. You don't have to know what 6 minus y is. You just have to write it down. Okay, seems a little weird. Let's do the next one. So 14 equals y minus z. So it's the same problem up here, except I added another variable instead of a number. So if I want to isolate y and get y by itself, I have to add z to both sides. So on the left, 14 plus z. I have no idea what 14 plus z is, so I'm just going to write 14 plus z. And on the right, I cancel out that minus z plus z cancels out, and I just have y. That's my answer. I isolated y. Y is 14 plus z. Okay, for this next one, 15 equals c over x. Again, same problem as above, I just added a variable. So if I'm trying to get c by itself, I have to do the opposite of divide by x. So I'm going to multiply both sides by x. So on the left, x times 15. I don't know what x times 15 is. I'm just going to write it as 15x. Now you could write x 15, but this is the proper way to write it. We usually put the constant in front. So 15x. And on the right, my times x divided by x canceled out, and I just got c. So I isolated C, I got it by itself. One more. So if I'm trying to solve for A like I was above, right now I have A times C. So I'm going to have to do the opposite of times C, which is to divide by C. So I get A equals 20 divided by C. So it's okay to have a variable in your answer when you're isolating a different variable. All right, so neither of these are what you're actually doing on the project. This next step would be what you have to do on the project, where there's just a lot of variables and not so many constants. So same thing, I'm still going to try to isolate x, just like I did here and here and here. I'm going to do the same thing. So to get x by itself, I am going to have to subtract y from both sides. So on the left, I end up with x, and on the right, I have z minus y. Well, I don't know what z minus y is, so I'm just going to leave that in my answer. X equals z minus y. You isolated x. On the next one, if I'm trying to isolate y just like I was on these other problems, I'm going to have to do the opposite of minus z, which would be to add z to both sides. So on the left, I end up with f plus z, and that's okay. And on the right, I have my y isolated, just like I was trying to do. Over here, t equals c divided by x. So I'm trying to solve for c. That's what I was doing on all of these problems. So the opposite of dividing by x is multiplying by x. So on the left, I have x times t. You can write that either way, xt or tx. And on the right, I just have c. I isolated c. Last one, if I'm trying to solve for a or get a by itself, I would have to divide by c. And so I have a equals, over here I have r divided by c. I'm just going to have to leave that r divided by c. So solving these literal equations or isolating one variable in these literal equations might seem kind of weird, but it's actually easy because you're just leaving the variables as they are. You don't have to know what z minus y is. You just write z minus y. So hopefully that will help you as you go through this project.